I do a lot of public speaking and I do a lot of traveling. And I had a grower come up to me and they said, we came to one of your conferences 15 years ago. He says, your story hasn't changed much. And I said, well, why would you say that? They said, well, all these companies come out with all this great new technology and different products and this and that. Says, you have the same boring story. It's like, well, guess what? Boring works. And good nutrition and good common sense doesn't go out of style. I'm Glen Rabenberg with Soil Works. We're going to talk about how to reduce your synthetic nitrogen needs on any and all crops. In the past years, a huge emphasis has been put on synthetic nitrogen. And many growers of various crops will say, our nitrogen bill goes up and up and up, and we're not getting any more yield. The cost of the nitrogen is higher, the volume of the nitrogen is higher, and the obvious question is, if you want to make some more money, you can't really control the market, you can't really control weather, but you can control your inputs. There's a lot of different nitrogens on the market. Slow-release nitrogen, sustained-release nitrogen, stabilized nitrogen, ammoniated nitrogen, ammonium sulfate, calcium nitrate, calcium chloride, all these different combinations of nitrogen are trying to react to a symptom. And that symptom isn't a nitrogen deficiency, it's a symptom of suffocation, and it's a symptom of poor soil health. To define healthy soil or healthy plant, either one, the definition I like is very simple and straightforward and short. Without disease or without impairment. Here's how you can reduce your nitrogen in the soil. Number one, you need to figure out and take a look at a science called plant physiology. What do I mean by that? Plant physiologists examine on what a plant is made of. And if we took the dry matter portion of any plant, took all the moisture out of it and dried it down to a dry matter basis, we would have a composition that would surprise many of you. The number one ingredient in that dry matter plant is carbon. 47%, give or take, depending on the variety of the plant that you're looking at, but 47% of the dry matter weight of a plant should be carbon. Second, 43% of that dry matter weight of a plant should be oxygen. The third ingredient in the dry matter weight of a plant is hydrogen. And hydrogen makes up about 4% of the dry matter weight of a plant. Nitrogen only makes up 3% of the dry matter weight of a plant, and the last 3% is made up of soil minerals. Why do I say this? If you take a look at carbon, oxygen, and hydrogen, it makes up 94% of the plant. Nitrogen only makes up 3%. If this plant is healthy, if this plant is disease-free, and if this plant has nutritional sustenance. Why all the big hubbub about more nitrogen? Because companies can make money off you. So, we want to take a look at how do you reduce your nitrogen needs. Well, number one, if you're breathing while you're watching this, can you smell nitrogen? Probably not, because we're used to smelling it. In the atmosphere, 78% of every breath we take is nitrogen. 78% of what we breathe is nitrogen. If this atmospheric air can go into the soil, there's your free nitrogen. But it's not quite that easy. You have to earn it. You have to qualify for it, and you have to establish where your ground is at and where your microbes are at. Number one, when you start looking at how to reduce your nitrogen needs, you need to see and evaluate how compacted, how tight, or how much surface tension does your soil actually have. This can be done with a penetrometer. A penetrometer has a T-handle, it has a actual gauge, and it has two different points, a larger point for sand, a smaller point for dirt and clay. Take the appropriate tip, put it on the end, steady downward pressure. Your soil should be between 100 and 150 psi. If you have sand and you're under 100 psi, you need to increase or create more surface tension because things leach through. So this atmospheric air that has all this great nitrogen in it will push down into the soil with a high pressure front, which is heavy sinking air, and that's Mother Nature's way of respirating the soil. If you have less than 150 psi in the soil, that air, atmospheric air with nitrogen and oxygen and all the goodies, will respirate the microbes. That high pressure front pushes the air down, a low pressure front brings it back up. That is the natural respiration of the earth, and it's been doing this since the beginning of time. When you look at your soil, you have to have the pressure right. If there isn't enough pressure, if you have sand, some of our growers will say, I've got some sandy fields and it's almost like that field has diarrhea. Things just leach through, just blows right through. I can't hold anything in that soil. So we want to establish that's loose, movable soil that nothing sticks in. The other extreme is high magnesium, heavy clay, where it's tight. It crusts. If you work it, it has lumps, clumps, and clods. The magnesium is the issue that's causing the problem. And what we need to do is we need to relax that magnesium and get the surface tension of the soil below 150 psi. The deeper this shaft can go at 100 to 150 psi, the deeper your respiration of the soil will be. Take a look at your crop, look at the natural root zone, and then you'll have a pretty good idea of how deep you want that air to go. So, number one is you got to make sure that your soil can breathe. If you're below 100 or over 150, you're not going to be able to reduce your nitrogen needs. Number two, please look at the carbon to nitrogen ratio in your soil. Not the soil organic matter, but the carbon to nitrogen. You're going to have to ask for it specially. They don't normally run it unless you ask for it. A lot of the experts, when asked about a carbon to nitrogen ratio, they'll take a big deep breath and go, oh my gosh, you probably got 8 or 10 times more carbon than nitrogen, making you think, oh gosh, I'm sitting good. Well, guess what? When you talk to the microbiologists that study the life of the soil, an 8-to-1 carbon to nitrogen just keeps microbes alive. They don't work. They don't reproduce. They're just there. We know people that are like this, but the soil microbes are starving if you have an 8 or a 10-to-1 carbon to nitrogen. Many years ago, we did some research on this carbon and nitrogen, and we found the same exact numbers as the NRCS did. And the NRCS put out a sheet that an 8-to-1, the microbes are just there, no benefit. 16-to-1 carbon to nitrogen, now they're just beginning to do some work. It's not the goal, but a 16-to-1 carbon to nitrogen is the first level that you'll see the, aha, this makes sense. I like what's going on here. Why am I talking about carbon to nitrogen when you want to reduce your synthetic nitrogen bill? Because there's these little microbes in the soil called nitrogen fixers. and they have to fix the nitrogen that comes from the atmosphere. What do I mean by that? Atmospheric nitrogen, let's just say my left fist and right fist is each an N of nitrogen. They're hooked together. And this is not plant available nitrogen. This nitrogen in a double dipole bond has to go into the soil. And the microbes, once it gets in the soil, have to split it, or an acid has to split it. So now you got an N here, you got an N here. If you have tight soil and there's no oxygen, it's impossible for a soil aerobic microbe to make NO3 nitrogen. Compaction limits oxygen, which cuts down on your free nitrogen that's in the air right now waiting to have you open the door and let it go into the soil. Ammoniated nitrogen, NH4, has to have hydrogen in order to hook to the nitrogen, and if the microbes don't have hydrogen, they can't make NH4. The goal on your carbon to nitrogen ratio is mid to upper 20s or low 30s. Good compost should be 30 to 1, 32 to 1, 33 to 1. And if we look back at what a plant is made of, if you add up carbon and oxygen and hydrogen and take a look at that ratio to nitrogen, you're in that 30 plus carbon, oxygen, hydrogen to 1 nitrogen. How do you reduce your nitrogen bill? Take a look at the air in the soil. Take a look at your carbon. The plant wants carbon. The plant wants oxygen. The plant wants hydrogen. Caveman chemistry, when you take carbon, oxygen, and hydrogen and combine them, let's just say we're a green plant and we lay our leaves out, gather sunlight, water, and minerals to make sugar. Sugar, simple sugar, is 6 parts carbon, 12 parts hydrogen, 6 parts oxygen. Photosynthesis is the essence of what the plant is made of. 94% of that plant is carbon, oxygen, and hydrogen. Why is everybody talking about nitrogen? Because you don't have carbon, oxygen, or hydrogen in your soil. If you want to decrease your nitrogen bill, take a look at what the respiration rate or the tightness or the looseness of your soil is. Take a look at your carbon to nitrogen ratio in the soil and start moving forward. And what you will see is when you get to 16, 17, 18 to 1 carbon to nitrogen, you will now be able to reduce your nitrogen bill. You cannot, you will not, absolutely impossible to cut back dramatically on your nitrogen bill without increasing your carbon and oxygen in the soil. We've covered a lot of information here today that you may not have heard from other people. Please do your research. If you have any questions, comments, or concerns, call us or email us at Soil Works. We'll do what we can to help you because our name isn't just our name, it's what we do. We get soil to work.